Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation from higher order linear differential equation. So let's get going. Problem solve d square plus 2d plus 1 into y equals to x cos x. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so 2 will be our order. And highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y plus 2dy plus y equals to x cos x. We know that d is a differential operator. Then d square will be d square by dx square. Now we can write our equation as d square y by dx square plus 2 into dy by dx plus y equals to x cos x. Here d square y by dx square is the highest derivative, so our order will be 2. And highest power of the highest derivative is a degree. Degree is 1. Now coming to the problem. Given differential equation, d square plus 2d plus 1 into y equals to x cos x, which is an operator form. F of d into y equals to q, where f of d equals to d square plus 2d plus 1 and q is x cos x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function. We will find complementary function using the auxiliary equation of, the roots of auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Right? Now let's find yc and yp. The auxiliary equation of homogeneous equation f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 2d plus 1, right? Let's replace differential operator by m, so that we'll get f of m equals to m square plus 2m plus 1. Now our auxiliary equation becomes m square plus 2m plus 1 equals to 0, right? We can write 2m as 2 into m into 1 and 1 as 1 square, and this is in the form of expansion of a plus b whole square, right? Then we can write it as a square, a plus b whole square, right? That is m plus 1 whole square. See, we have m square plus 2 into m into 1 plus 1 square. So we can write it as m plus 1 whole square equals to 0. We can write m plus 1 whole square as m plus 1 into m plus 1 equals to 0. Now equate each factor to 0. If m plus 1 equals to 0, then m equals to minus 1. Since m plus 1 is repeating twice, so we'll get m equals to minus 1 and minus 1, equal roots. Therefore, m equals to minus 1 are the roots of f of m equals to 0, which are equal. We know that when two roots say m1 and m2 are equal, then yc looks like c1 plus c2x into e power that equal root into x. Since we have two equal roots, so we'll get two terms under brackets. Now our complementary function will be yc equals to c1 plus c2x into e power that equal root into x. Then yc equals to c1 plus c2x into e power minus x. So we got yc now. Let's find yp. We'll find particular integral using 1 by f of d and q into q, right? We have f of d and q, where f of d is d square plus 2d plus 1 and q is x cos x. So this is of 1 by f of d into x into v form. Here we can use the formula 1 by f of d into x into v is x into 1 by f of d into v minus f dash of d by f of d whole square into v, or just take 1 by f of d common from these two terms, we'll get x minus f dash of d by f of d into 1 by f of d into v. We just took 1 by f of d into v common from the two terms, right? Now we are going to utilize this formula is equals to x minus, if f of d is d square plus 2d plus 1, then f dash of d will be 2d plus 2, right? Plus 0, which is 2d plus 2. Or you can write it as 2 times d plus 1. If you take 2 common from these two terms, right? We'll get x minus f dash of d is 2d plus 2 by f of d is d square plus 2d plus 1 into 1 by f of d into v. Here v is cos x. And this of 1 by f of d into cos ax form, right? So we can simplify this. Now, compare cos x with cos ax, then for a equals to 1, we'll find d square, which is given by minus of a square, which is equals to minus of 1 square, is minus 1. Now we need to check what happens if we replace d square by minus 1 in the denominator. The denominator must be non-zero. What happens if denominator is 0? We'll get the total term becomes 1 by 0 into cos x. Since 1 by 0 is undefined, so total term becomes undefined, right? So the denominator must be non-zero, right? Now take the denominator part, d square plus 2d plus 1, and see what happens if we replace d square by minus 1. Just replace d square by minus 1, we'll get minus 1 plus 2d plus 1, which is equals to 2d, which is non-zero, right? Since by replacing d square by minus 1, we get the denominator non-zero. So we'll replace d square by minus 1 in this term. We'll get x minus of 2d plus 2 by d square plus 2d plus 1 into, replace d square by minus 1, we'll get 1 by minus 1 plus 2d plus 1 into cos x. Here plus 1 minus 1 gets cancelled. Then we'll get yp equals to x minus of 2d plus 2 by d square plus 2d plus 1 into 1 by 2d into cos x. This is equals to x minus 2d plus 2 by d square plus 2d plus 1 into, split 1 by 2d as 1 by 2 into 1 by d into cos x. The next step, we'll find integral of cos x, since 1 by d is an integral operator, and take this 1 by 2 constant outside. We'll get 1 by 2 into x minus 2d plus 2 by d square plus 2d plus 1 into integral cos x dx. Which is equals to 1 by 2 into x minus of 2d plus 2 by d square plus 2d plus 1 into integral cos x dx is sin x. This becomes 1 by 2 into x sin x minus 2d plus 2 by d square plus 2d plus 1 into sin x. See again, d square appears in the denominator and we can write this as 1 by 2 into x sin x minus 2d plus 2 into 1 by d square plus 2d plus 1 into sin x, right? See, this is of 1 by f of d into sin x form. Then a equals to 1, we'll find d square, which is given by minus of a square, which is equals to minus of 1 square equals to minus 1, right? Now replace this d square by minus 1, and we know that by replacing d square by minus 1, we'll get the denominator non-zero. Okay, so nothing to worry, we'll just replace d square by minus 1. We'll get 1 by minus 1 plus 2d plus 1 into sin x. Here plus 1 minus 1 gets cancelled and we'll get 1 by 2 into x sin x minus 2d plus 2 into 1 by 2d sin x. This is equals to 1 by 2 into x sin x minus of, we can write 2d plus 2y into 1 by 2d as 2d plus 2 by 2d into sin x. This becomes 1 by 2 into x sin x minus, see in this fraction we are having two terms in the numerator and one term in the denominator, so we can split this into two terms. 2d by 2d plus 2 by 2d into sin x. 2d by 2d is 1. 2 gets cancelled and we'll get 1 by 2 into x sin x minus of 1 plus 1 by d into sin x, which is equals to 1 by 2 into x sin x minus of 1 into sin x is sin x plus 1 by d into sin x. We know that 1 by d is an integral operator, so in the next step we'll find integral sin x here. We'll get 1 by 2 into x sin x minus of sin x plus integral sin x dx is equals to 1 by 2 into x sin x minus of sin x plus integral sin x dx is minus cos x. So this becomes 1 by 2 into x sin x minus 1 by 2 into sin x plus into minus cos x, or 1 by 2 x sin x. Now take this minus inside the brackets, we'll get plus 1 by 2 into minus sin x minus into minus plus cos x. This is equals to 1 by 2 into x sin x plus 1 by 2 into, write the term involving plus sign first, you'll get cos x, and then term involving negative sign. Or you can write this as 1 by 2 into x is x by 2 into sin x plus 1 by 2 into cos x minus sin x. These are required yp. Now we can write the general solution since we got yc and yp. The general solution is given by y equals to yc plus yp. Then y equals to yc, we are having c1 plus c2x into e power minus x plus yp, x by 2 sin x plus 1 by 2 into cos x minus sin x. This completes the problem. Also, you can solve yp simply by replacing d square by minus 1 in the denominator. This is also 1 by f of d into cos ax form for a equals to 1 We'll find d square, which is given by minus of a square, which is equals to minus of 1 square is minus 1, right? Now replace d square by minus 1 simply. We'll get x into 1 by minus 1 plus 2d plus 1 into cos x minus 2d plus 2 by minus 1 plus 2d plus 1 whole square into cos x. Minus 1 plus 1 gets cancelled and you'll get x into 1 by 2d cos x minus 2d plus 2 by 2d whole square is 4d square, or just write 2d square into cos x is equals to x by 2 into 1 by d cos x minus, take 2 common from the numerator, we'll get 2 times d plus 1 by 2d whole square is 4d square into cos x. 2 ones are 2 twos are. This becomes x by 2 into integral cos x dx minus 1 by 2 d square into d plus 1. We'll just split d plus 1 by 2 d square as 1 by 2 d square into d plus 1, okay? Into cos x is equals to x by 2 into integral cos x dx is sin x minus 1 by 2 into 1 by d square into d cos x plus 1 into cos x is cos x is equals to x by 2 sin x minus 1 by 2 into 1 by d square into derivative of, here d is a differential operator, right? Derivative of cos x is minus sin x plus cos x is equals to x by 2 sin x minus 1 by 2 into 1 by d into split 1 by d square as 1 by d into 1 by d into minus sin x plus cos x, or just write it as plus cos x minus sin x. Is equals to x by 2 sin x minus 1 by 2 into 1 by d into operate 1 by d firstly. We'll get 1 by this cos x minus 1 by d sin x. We know that 1 by d is an integral operator, so we need to find integral in this step. We'll get 1 by d into integral cos x is sin x minus integral sin x is minus cos x. This becomes x by 2 sin x minus 1 by 2 into 1 by d into sin x minus into minus plus cos x. Now operate 1 by d. We'll get x by 2 sin x minus 1 by 2 into 1 by d sin x plus 1 by d cos x. We know that 1 by d is an integral operator. Then we'll get minus 1 by 2 into integral sin x is minus cos x plus integral cos x is sin x. Right? Now, take this minus inside the brackets or multiply these two terms with minus. We'll get x by 2 sin x plus 1 by 2 into minus plus cos x minus into plus minus sin x. We'll get the same yp. Okay? And the general solution will be y equals to c1 plus c2x into e power minus x plus yp. X by 2 sin x plus 1 by 2 into cos x minus sin x. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.